Welcome back everyone. In this lesson, we are going to be creating our player game object. This is going to be our player object, which we are going to attach various different components to so that in the future we can start scripting it to move around, jump, and interact with all the various different game elements. So let's go over to the Unity engine right now. And inside of here, what we're going to do first of all is go to our sprites folder, go to our player folder, and I'm going to select this alien yellow stand sprite right here and drag that into our hierarchy. So you'll see it created a brand new game object here inside of the hierarchy, but we are not going to be attaching our components to this object. We can zoom in and see it right here. Instead, we are going to be attaching our components to an empty game object, which is going to have this sprite as a child. And the reason why is because when working with sprites and all that, it's generally good practice to have the most parent object be empty, as that is sort of like a blank canvas for all your components, and it will allow us to do various other things. Maybe eventually we want to maybe scale up the sprite, maybe we want to modify it in some way that we don't want to apply to the main overall object. So what I'm going to do is right click here in the hierarchy and go create empty. And this is going to create a brand new game object, but you'll see there are no components here in the inspector apart from the transform component. And that is because it is a blank canvas and we can attach whatever we wish. So what I'm going to do is I'm going to rename it here from game object to be player. Hit enter to assign that. I'm going to set the position to be 0 on the X, also then 0 on the Y and 0 on the Z. So you can see here in our scene view, it is nice and centered. And to move around our scene view, we can scroll in and out with the scroll wheel and click in the scroll wheel and hold in order to drag around like so. You can also do the same with the right mouse button. So we've got our player here. Now let's select our sprite that we dragged in previously and make that a child of player by dragging it over the player object here in the hierarchy. So there we go, our sprite is now a child of the player, and in fact I'm going to rename this to be sprite, so if we're just having a glance we know exactly what this game object is. There we go. And since if we select our player, this is the center point, we want our player's feet to be standing on this center point here, because we want our player's feet basically to be at the pivot point or the center point of our game object. That just makes it easier for a bunch of different things, such as detecting the ground, and is overall just the best practice in game development. So what we're going to do is select our sprite here, and I'm going to drag this up so the feet are just touching that bottom line here. And in fact, I reckon we could just set the Y to be 1 exactly, and if we zoom in close, select our player, you'll see that the center point here is pretty much in line with the feet, which is what we want. Okay, so there we go, we got our player sprite. Now what we need to do is start attaching some of the components. And first of all, what we need is a collider. Now, since we are making a 2D platformer, our player is going to be jumping around, and in order to detect where the ground is and avoid just falling straight through the map, we need a collider, a component which basically gets our player and puts a solid shape around it so it can bump into things, it can interact with various other things as well. So here in the inspector with our player selected, I'm going to go add component, and I'm going to look for a capsule collider 2D right here. Hit enter, and you'll see we have this green outline in our scene view now over our player, and this is the bounds of our capsule collider. Now, when creating players in both 2D and 3D, generally having a capsule collider is one of the best options, mainly because it is very good for going over bumps, because if you have small little bumps, you're not going to catch it if it's a square, for example. And overall, it matches the body shape of our player as well. So, as we can see though, first of all, this isn't really matching the dimensions, it's kind of low down. So what we need to do is move it up a bit. So over here in our Capsule Collider 2D component, you'll see that we have an offset vector right here. And you'll see there is only an X, Y, but no Z. And the reason why is because when working with 2D inside of Unity, we don't use the Z axis because the Z axis is for forward and back. But since we're only in 2D mode, we only need the X and Y axes, okay? So remember that when working in 2D, you don't need to worry about the Z at all, okay? We can have this Z at 0, we could have this at 5. It does not matter whatsoever. So in our Capsule Collider 2D component here, I'm going to get our offset and I'm going to make this around 0.5. So there we go. You'll see now that this capsule collider, the bottom is touching our base of our game object and the top is a bit over our player's head. Now we could go through and make this exact, but I reckon it's pretty good right here. We probably don't want too much of a gap over on the sides, so I reckon this is very good how it is right now. And along with our Capsule Collider 2D component, we need to give our player some physics, because right now, if we were to press play, up here at the top of the screen, you'll see that nothing happens. Our player isn't being affected by gravity or anything like that. So what we need to do is attach a brand new component to our player called a rigid body 2D, and make sure it is the 2D version. Whenever we are working in 2D mode, there's most likely for colliders and rigid bodies going to be a 3D and a 2D version, so make sure of course you use the 2D version. And a rigid body 2D is a component which basically adds physics to whatever it is attached to. So if I'm going to press play right now without changing anything, you'll see that we spawn in and our player starts to fall. It is being affected by gravity. And not just gravity with the rigid body, it also implements mass, drag, gravity, collision detection, and we can also modify our velocity, which is what we're going to do for moving our player around. Okay, so we have our player here, they're falling, but we don't really want them to fall straight down. We want to be able to stand on a platform, so what we're going to do quickly here is create a little platform that we can walk on. So I'm going to go to my sprites folder here, I'm going to go to tiles, and I'm just going to look through this list here for a nice grass tile. Right here, grass mid, we can drag that in. I'm going to set its position to be 0 on the X here and negative 0.5 on the Y. I'm going to actually then select this, add component, and I'm going to add a box collider 2D to this grass mid object. You'll see there is now a green outline around the box. So if we press play, you should see that the player doesn't fall through the ground because there is another collider below them which is stopping them from falling, okay? And all of this was done by just adding components. We didn't have to script any of this at all. The gravity, the physics, that is all implemented for us automatically thanks to this rigid body component and the colliders that we have attached to both our player and our ground. So in the next lesson, we are going to actually go ahead and begin scripting our player movement. Okay, we got our player object here. Now let's get them moving around. So thanks for watching, and I'll see you all in the next lesson. Welcome back everyone. In this lesson, we are going to begin working on player movement. In the previous lesson, we set up our player game object, attaching its components. Now we can get this player actually on the ground and moving about. So what we're going to do is head over to their Unity engine right now. And to start off, I'm going to be creating a brand new folder down here in the project browser. So I'm going to right click here, go create folder, and I'm going to call this one scripts. Okay. Inside of this scripts folder, we are going to create a brand new C# script for our player. So we can right click, go create C# script right here, and I'm going to call this one player. Hit enter to create that. And then what we can do is select our player game object here in the hierarchy, scroll down to the bottom in the inspector, and drag in the player script. Okay, you should see a blue line in the inspector appearing. Just let go, and there we go. The player script is now attached to the player game object as a component. We can now assign logic to it, and that will be applied to our player. So next, what we want to do is just double click on the player script right here in the project browser to open it up inside of Visual Studio. So now what we need to do is first of all create some variables to keep track of some information that we need. First of all, we need to keep track of our player's move speed. How many meters per second do we want to move at, okay? So underneath where it says public class player, we want to go to a new line here, and we want to go public float move speed and end it off with a semicolon because we are stating something here. We are defining a variable. Now you'll see that we have public here before float. And the reason why we have public here is because inside of C# there are two types of variables or two types of scope. You have public and private. Having something as public, that be a variable or a function, means that it can be accessed outside of this script, okay? And in order for it to be seen inside of the inspector needs to be able to look inside of this script and see this variable. And that can be done by defining it as public. Now, if this is a variable that we are only ever going to use inside of this player script right here, no other class or no other script needs it, then we can define it as private, okay? But since we want this to be displayed in the inspector, we need to make it public. And in the inspector, we can then modify it, change its value. Now, we need a reference to our rigid body component in order to move around, okay? We need to modify our rigid body's velocity, and in order to do that, we need our component, the rigid body component. So for that, I'm going to create another public variable, and the type of variable is going to be of type rigid body 2D, like so. The name of the component, you should see that it is a different color from float, and we are going to call this one ridge, which is just a short for rigid body, okay? There we go, we've got our two variables right here. Now, if we save with Control S or Command S on a Mac, or click up on this little save button here, that'll save the script. We can return to the Unity editor right here, and you should see with our player selected, in the inspector here, if we scroll down, we can see our player component, and it has two new properties. So for move speed, I'm going to assign this to be 4, so we're going to be moving at 4 meters per second. And for the rigid body property right here, we are just going to drag in our rigid body component here. So click and drag on the name, drag that into the field here, and there we go. We can save that. Let's go back to our script now, where we are then going to start implementing the player movement. So first of all, let's actually delete our start function since we don't need that. Again, the start function gets called right at the start of the game. We don't need that. And in fact, we aren't going to be using the update function just yet either. For the movement, we aren't going to be using it, but when we are jumping, that is when we are going to use the update function, and I'll explain why. The function we are going to use is called, if we go void fixed update, okay, we want to use the fixed update function, and you should see that the name is highlighted in blue here. Now, what fixed update is, it's very similar to update, right? Update gets called every single frame. So every single frame, the code in between these two brackets gets called. If you want to do movement, if you want to do rotations, or whatever you want to do every frame. But fixed update gets called at a set time rate, okay? So fixed update gets called every 0.02 seconds by default. And there is different benefits between these two. Update, it gets called every single frame. So if you're having a game at 60 FPS, this gets called 60 times a second. If you're having a game at 100 FPS, this gets called 100 times a second. Whereas fixed update, no matter what the FPS is, it always gets called every 0.02 seconds. And the reason why is because with Unity's physics, the physics engine, it works the best if you have it at a fixed time step. Sometimes when you do physics inside of the update function, things can get a bit weird. So it's recommended by Unity that you write your physics code inside of the fixed update function, which is where we are going to be setting our velocity. So inside of the fixed update function here, we are going to begin moving our player around, and we'll be working on that in the next lesson. So I'll see you all then. Welcome back everyone. In this lesson, we are going to be continuing straight from where we left off inside of our player script right here. In the previous lesson, we created our player script, we attached it to our player game object. Inside of the script, we created our move speed and ridge variables, which we're going to be using in order to modify our velocity. And we created the fixed update function, which gets called at a consistent 0.02 seconds and is ideal for working with physics. So, first of all, inside of our fixed update function, we need to get our input from our keyboard because we're going to be moving with our left and right arrow keys. And what we can do to get this left and right input is by using Unity's horizontal axis, okay? And I'll show you what we mean. So first of all, I need to create a little temporary variable here, which is going to keep track of our input. So I'm going to go float x input like so, and this is going to be equal to input.get axis, and in between two parentheses, we want to create a string with two quotation marks called horizontal like so, okay? Make sure there is a capital H, as that is important to have it exact like so. And what this does is it basically gets the input from the horizontal axis, and this is a range from -1 to 1. Okay, it's a float from -1 to 1. -1 meaning it is going left, +1 meaning it is going right, and 0 meaning it is not being pressed at all. So if we press our left arrow key, this axis is going to be equal to -1, and if we press the right arrow key, this axis is going to be equal to +1, and if we're not pressing anything at all, it is going to just be equal to 0. And this also applies to the A and D keys on the keyboard as well. And also if you have a controller, that is also along the left joystick, left and right, okay? So with this horizontal axis, what we can then do is assign this to our rigid body's velocity. So to do that, I'm going to go to a new line, and I'm going to go rig.velocity. So what we're doing here is we're getting our rigid body component, or the reference to it, and we are accessing its velocity variable. Now, the velocity variable here is a vector 2, okay, not a vector 3, because inside of Unity, when we're working with 2D, we only need to worry about the X and Y axis, okay? We don't need to worry about the Z axis because that is for forwards and backwards, that is for depth. So with the rigid body 2D velocity, we are only working with a vector 2, an X and a Y value. So this velocity is going to be equal to, and we're going to be creating a new vector 2 here. So new vector 2, parentheses like so, and we need to give it an X and a Y value. Now X is left and right, so we want to modify that based on our X input variable just above. So for our X, we are going to make this X input, and multiply that by our move speed, okay? So we do have that varied move speed. We can then go comma, and we need to enter in a Y velocity. Now, what we don't want to do is just enter in 0, okay? You may think, okay, we don't want to move along the Y, so we'll just put 0 there. Well, the problem with that is once we actually start moving left and right, we won't actually be affected by gravity anymore because we are overriding that by manually setting our velocity to be 0. So we're never going to fall, we'll never be able to jump. So what we need to do is instead of setting this to a hard number, we need to basically make our Y velocity whatever it currently is, okay? We just need to make the Y velocity the Y velocity. So for this, I'm just going to go rig.velocity.y, okay, for the Y value here, and that will make it so that we can move left and right, and we can also be affected by gravity at the same time. We're not going to be setting our Y velocity at all here to be anything else than what it currently is. Okay, so we can save that, return to the Unity editor now, and inside of here, what we can do is click on the play button, and we can use the left and right arrow keys, and we should see that we start to move around. We're moving around, but it's not really what we want. We have fallen over. We're moving still, but as you can see, our character is kind of not standing upright. So how do we fix that? Well, I'm going to click play again to stop playing, and I'm going to go over to the inspector with our player game object selected, and let's go to the rigid body component right here. Okay, now you'll see that there is a little drop down here called constraints. Let's open that up by clicking on the arrow, and you'll see there is freeze position and freeze rotation. These basically freeze the position or rotation for a certain axis so that physics aren't affecting it. Now, since we don't want to rotate left and right, we don't want to basically fall over, we want to enable freeze rotation on the Z axis. This will mean that the physics does not affect the rotation of our player, which is what we want. We only want it to affect our position. So we can press play again, and you'll see that our player is no longer falling over, and we can move around left and right. We can still fall off the platform though, which is fine. So let's actually expand this a bit. I'm going to select our grass mid, and I'm going to go Control D or Command D if you're on a Mac to duplicate. I'm then going to hold down the Control key, or the Command key, and I'm going to move this left. And you'll see I got snapping set on, so I can basically move it at set increments off to the side. Duplicate that again, bring that over here, and there we go. So we've got our platform. It's a bit bigger now, and there we go. We are moving around. Now, we probably also want the camera to be following our player, so we'll unpress play. And what we want to do is make the camera a child of the player. Now, what this means is that when our player moves, the camera moves as well. So all we have to do for this, select our camera, and drag it into the player so it is now a child. So if we press play, you'll see now that the camera moves when our player moves as well. There we go. We might want to modify this a tiny bit though, so what I'm going to do is go to our game view here. You may see that the aspect ratio is a bit weird. It may be on free aspect for you. So what I'm going to do is I'm going to select free aspect and I'm going to change this over to 16:9. Okay, this is a 16:9 aspect ratio, and this is pretty much what all 1080p 4K monitors are like. So most of the time, pretty much everybody who's going to be playing your game will be playing in this sort of aspect ratio. Now, we probably want to zoom the camera in a tiny bit, so I'm going to go over to the inspector with our camera selected. I'm going to set the size to be 4 here, and on the Y, I'm going to make this, let's just say we make that 1. So it's a bit higher up than the player, and it is a bit zoomed in. So we can press play, and there we go. We can move left and right. The camera follows, we can fall off, and yeah, just like that. So we have play movement set up. Now, in the next lesson, we are going to be looking at how we can implement jumping. Okay, that's going to be a big part of our game as we're going to be needing to jump between platforms, jump to avoid enemies. So, in the next lesson, we'll be working on that, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be looking at implementing player jumping for our 2D game here inside of Unity. So let's go over to the Unity editor right now. And in the previous lesson, we set up horizontal movement. So with the arrow keys or with the A and D keys, we can move left and we can move right. And we also have the main camera as a child of our player so that it follows us along if we even fall off the platform here. So now what we need to implement is the ability for our player to jump. So let's go over to our player script right here. In the previous lesson, we set up our movement in the fixed update function. Now, for our jumping, we can go over and do that inside of the update function because we need to basically be detecting the frame that we press down on the jump key. And with the fixed update, there is a chance that it could skip over that frame since this doesn't necessarily get called every frame, only every 0.02 seconds. So what we want to do first of all is create a brand new variable, and this is going to keep track of our jump force. What sort of force are we going to apply upwards when we want to jump? So I'm going to add in a new variable here. I'm going to call this one our public float jump force. Okay, there we go. And then off with a semicolon as well because we are defining a variable right here. Save that. Now down inside of the update function here, which gets called every frame, what we want to do is first of all detect when we press the jump button. Now for us, I'm just going to be making that the up arrow key on the keyboard. So to detect if we are pressing the up arrow key, we can go if to create an if statement. In 2 parentheses here, we can go input dot get key down. Okay, and inside 2 parentheses then we can enter in a key code for the key that we want to check. Now to do this, we just go key code in capital K, capital C, dot, and you'll see there is a large list here with various different keys. Every single key on the keyboard, joystick, and mouse that we can choose. So I just want to search for up arrow right here. And there we go. Hit enter to select that. Add in our 2 squiggly brackets like so. And now this if statement will be true on the frame that we press down the up arrow key, okay? Only on that one frame. You can also do get key up for the frame that the key is released, and get key, so input.getKey, which is just every frame that that key is held down, okay? But we only want to know the frame that the key is pressed down, so we are using input.getKey down, okay? So on the frame that the up arrow is pressed, what we want to do here is basically add force to our player upwards, okay? And that is done inside of the rigid body component. So we have our rigid body reference right here, and like modifying our velocity right here, we can just go ridge dot, and we want to call it the add force function right here. Now this function, it takes in a vector 2 for the force, and this force is the direction and speed at which we want to move. Now since we want to go up, we can just then go vector 2 dot up, which is 0 on the x and 1 on the y. We want to then multiply that by our jump force, so we can vary how fast and how hard we jump over in the inspector. And then what we want to do is add in a comma, and you'll see there is another input here that we can have for the function, and that is a force mode 2D. So if we go force mode 2D dot, you'll see there are two options here. There is force and impulse. Now, when adding force, we can choose if we want to have a gradual increase in speed. So for example, if you were pushing a car or maybe trying to push something very heavy, you'd start off slow and then you'd build up momentum over time. Okay, that is what force would be. Impulse, on the other hand, is instantaneous velocity. So think of if you're hitting a golf ball with a golf club, that golf ball is going to be moving instantaneously the moment that it gets hit. Okay, there is no gradual increase in speed. It is going to be moving fast straight away and then gradually lose speed over time. So that's what we want to do for jumping. We want to have an instantaneous force upwards. So we'll go force mode 2D dot impulse and end that off with a semicolon like so. And there we go. So in the update function here, what we're doing is we're checking to see when we press the up arrow key. And on the frame that the up arrow key is pressed, we are adding force upwards based on our jump force here and at a force mode 2D of impulse. So we can save that, return to the Unity editor, and what we're going to do is select our player here. In the inspector, scroll down to the bottom, and we are going to modify our jump force. I'm just going to set this to 5 by default so we can test it out. Press play, and if we press the up arrow key, you'll see that we jump upwards. There we go, the platform below us is moving away, so the jumping works. But one problem is that we can keep pressing the jump button even though we are not standing on the ground. As you can see, I can fall down, I can spam the jump button so I fly up in the air. But yeah, that is something we do not want in our game. So the way we can fix that is by implementing ground detection. And ground detection basically checks to see, okay, when we want to jump, we can only jump if we are standing on the ground. And that is something we are going to be adding in the next lesson. So I'll see you all then. Welcome back, everyone. In this lesson, we are going to continue with our jumping mechanic for our player right here. In the previous lesson, we set up the ability to jump. If you can see here, we can press the up arrow in order to jump, but one problem is that we can keep jumping up. Now, we don't want this, so what we're going to do is set it up so that we can only jump if we are standing on the ground, okay? So let's go over to our script right here, our player script, and in the update function is where we set up the key press condition, and then we added force right here. So what we want to do now is create a brand new function which is going to return either true or false depending on if we are standing on the ground, okay? So underneath the update function here, I'm going to go bool and then is grounded, okay? 2 parentheses like so and the squiggly brackets. Now what this bool means is basically what value are we going to be returning, because when you have a function, you can decide if you want the function to return a value, because with a function you can give it inputs and it can output values as well, okay? It's sort of like a little factory. You give it something, it has an algorithm or whatever you want to do with that something, and then it outputs it to you, outputs a value. In our case, when we call the isGrounded function, we want to get a result of true or false, okay? You see in like the update function and the fixed update function, their return type is void, meaning that they don't return anything, okay? Because these are just functions that we call and they just do what they do. IsGrounded here though, we want to get a return value from that. And the way we're going to do this is with something known as a raycast. Now with a raycast, you give it a position and a direction, and think of it as a laser beam, okay? You have the laser pointer in one position and you aim it in a certain direction. You press the button and it shoots a laser, okay? And we can get information on what object it hit, how far it hit, or we can define a certain range at which this raycast can go, okay? So we are going to have a raycast that is at the base of our feet, pointing downwards, about 20 centimeters, okay? So if we jump, we're going to check, okay, is this raycast hitting a object below us? And if so, then we can jump. Otherwise, if it's just hitting air, that means we're up in the air and we cannot jump. So to do this, I'm going to go raycast hit 2D. I'm going to create a variable called hit of type raycast hit 2D. And this is going to be equal to physics 2D.raycast and put 2 parentheses here. Now, what are we doing? Well, first of all, I'm creating a variable here called hit, and this is of type raycast hit 2D, which is basically a data type that contains information of the object that we are hitting with the raycast. And over here where we go in physics2d.raycast, this is where we are actually casting the raycast. So in these two parentheses, we need to give it 3 values. First of all, a position, second, a direction, and third, a distance. How far do we want to shoot the raycast? Well, for the position, we want this to be our feet, so our center point of our object. If you remember, a few lessons ago, we made it so that our object, its center point is at its base, so we can just go transform dot position for the center point. Then we need a direction, and this direction is going to be downwards. So for this, we can just go vector2 dot down, which is 0 and -1 on the y. And for the distance, we don't want this to go too far. We're only going to go 0.2f, which is around 20 centimeters. Make sure you add the f at the end of float here to define this as a float. And there we go. Make sure you have a semicolon, and that is that line of code done. And now what we want to do is just return true or false for whether or not we hit anything. And to do that, we can just go return and then hit.collider doesn't equal null. So what we're doing here, whenever we raycast something, and if it hits an object, it is going to basically get that object's collider and store it inside of this hit variable. Now, what we're returning is a condition of whether or not this collider doesn't equal null. And in computing terms, null basically means nothing. So if this collider that we hit does exist, if we hit something, it is going to return true. Otherwise, if this collider doesn't exist, if it's nothing, then we are going to return false. Okay, so that's what this function is doing right here. We are basically shooting a little laser pointer 20 centimeters below our feet, and we are detecting whether or not we hit anything with it. Okay, so what we can do now is back in the update function where we are checking to see if we have pressed the up arrow key. Inside of this if statement, we want to go and like so. So we're checking 2 conditions. And for here, we just want to go is grounded like so. Okay, we're calling that is grounded function. And this is going to return true or false. And only if both of these conditions are true will this ridge.addForce function get called. So we can save that. We can then return to the Unity editor, and hopefully when we press play, we'll be able to jump first of all because we're standing on the ground. So here we are, we can move around, and if I jump, there we go, we can jump in the air. Now let's try and press jump twice. I jump. Now the reason why we can still jump is because sometimes with the raycasting, if you have the raycast point be at the base of a collider, it can sometimes clip into that, and there may be some floating point errors there. So what we're going to do is go to our isGrounded function, and where we have our transform.position here, we want to add a very small number below us, okay, just so it's outside of that collider. So I'm going to go plus new vector 3, and we're going to go 0 on the x, negative 0.1 on the y, make sure there's an f after that for float, and 0 on the z. Okay, so we're having basically 10 centimeters below our feet, we are casting the raycast, just so it doesn't accidentally clip into our collider, which is of course what's happening right here. So save that, return to the editor, we can then press play, and now you should see that we cannot jump multiple times. Right now I'm spamming the up arrow key, and we are only jumping when we hit the ground, which is good. And if we jump off the edge, you'll see that we cannot jump. So that is how we can set up our jumping inside of Unity here with our 2D character. Now in the next lesson, we are going to be working on setting up our enemies. Okay, we have our player, now we need an obstacle to avoid. So I'll see you all then in the next lesson.